Hey, welcome to another live Wells Tech training event. We are so happy you are here. And you know what else is here? Summer. Yes, summer is here. And you may think that we live in an air-conditioned place. Well, you are wrong.
Yeah.
You are wrong. It is not air-conditioned in our shop. It's just like your shop. And it's very warm in here today.
It is, yeah.
We waited for summer for months, and here it is. And now we're complaining about that.
Right.
All right. Today we're going to be talking about EVAP systems, specifically on an 07 Pontiac Grand Prix, a car you're very familiar with.
Yeah, if anybody wants to buy it, let me know.
Right, it's up
Keep
for
showing
sale.
up in
It's
here.
up for sale, yeah. But you had a problem with a P0455,
Right, yep,
a
large leak.
and it turned out to be a vent solenoid, we think, at this point. That's what it was, and what we're going to do today is we're going to go through the system, how it functions, but we're going to look specifically at that vent solenoid because we did some out-of-the-box testing on it to really verify that's what failed. And, well, come down the road with us as we get going. But before we get started here today, oh yes, it's time for the t-shirt giveaway. And by the way, we do have 3X t-shirts if you were wondering. All right, here's the question, and we're going to do kind of a question just like we did last time with the ASC type question. Technician A says the EVAP vent solenoid is normally closed. Technician B says that the purge solenoid is normally closed. Who is correct? Is it A, B, both, or neither? Okay, there you go. Put in your answer, A, B, C, or D, and you know, send us a chat on that, and we'll answer it later in the broadcast. Perfect. And if you do have it correct, we'd be glad to send you out one of these cool t-shirts of your size, not necessarily 3X.
Or not the toddler size either.
Not the toddler size, we got them all. We got, and we're kind of thinking about doing different colors now too, and different things like that, so got some different things coming up in the marketing, which would be cool. All right. Let's get started by first looking at how the system is put together.
Okay.
All right, so let's bring up that diagram. All right, very good. And you can see, let's start with the fuel tank. Excuse me. And on the fuel tank, you can see that there's a filler neck that has a sealed gas cap. You have to have a sealed gas cap on there today. And also you can see in there a rollover valve. And we're going to get into more detail on that rollover valve, and that comes into play when you are smoking it, you're looking for a leak, that kind of thing. Yeah. All right? And very important part. And it's not on every vehicle either. So when you do run into it, you will know. Okay, also a fuel tank pressure sensor. And you can see then it leads down to, we have a vent solenoid, and we have a purge solenoid, and we have a canister. Okay, and that's pretty much it. Those are the parts that are associated with it. But we also have a test port on this one, and which is interesting too because this is the diagram for your vehicle.
Right, exactly.
And I don't know if we're blind or what, but couldn't find it.
I didn't see it, no.
Couldn't find the test port. So we're going to show you how we actually smoked that thing. Yeah. And it was pretty easy. Right. You know, it isn't a lot of, you know, a lot of problems.
Yeah, not all vehicles are going to have that test port, so
no,
got to find other ways.
Yeah, and if they do have it, they might hide it where you can't find it, so they might as well not have it, right? Okay. All right. So, is there anything you want to go through, maybe through the flow with this?
Yeah, sure.
Would you like that?
So when a EVAP system goes ahead and performs its monitor test to see if the system is functioning and it's sealed up, remember. An EVAP system is designed to not let your fuel vapor escape into the atmosphere. You don't want to be killing those flowers, and hydrocarbon emissions are a bad thing. And
that's true. You know, when you look back and you saw, you know, emissions like in the 50s, it was terrible. I mean, they even kept kids from going to school because the smog was so deep, like in LA, that they were afraid you send your kid out there, he's going to croak. Right. You know, so, and they were right. You know, it wasn't a good thing. So this is a good thing for everybody.
Yeah. So when the system seals up, it's going to go ahead and turn the purge solenoid. It'll turn that on, and now that's connected to intake manifold vacuum. It'll turn that solenoid on, which opens it up, and sends vacuum through the system. At that same time, it closes the vent solenoid.
So it activates that one and closes. By the way, we just answered the question if you were paying attention.
It closes the vent solenoid. So at this point, the system is entirely sealed. There should be no leak or anything out of there. So the purge solenoid will draw vacuum down on the entire system. Roughly, what did we find? About 5 to 10 inches of vacuum?
5 to 10 inches of water.
Of water.
Water,
right.
and there's a big difference there. And be careful that you don't add too much vacuum to the system, sure, or too much pressure to the system, because you will blow it apart. It's 5 to 10 inches of water is like 1/4 to 1/2 inch of mercury, and that's what you're used to measuring with your vacuum pump.
Okay.
That's inches of mercury. So be careful with that.
Yep, okay. And then also be careful with pressure. These systems are designed for a very, very low pressure,
very
especially
low,
when hooking up a smoke machine. And that
right,
kind of thing.
both ways.
Yep.
It works both ways. You want to stay under like that 1/4 to 1/2 inches of mercury, pressure or vacuum.
Right.
Yep.
Okay, perfect. So the purge solenoid is drawing vacuum on the entire system, the canister, the tank. And if you notice, our gas tank right here is about half full.
That's a good point.
That's because in order for the EVAP system to test itself, to monitor itself, to know if it's working, the fuel tank needs to be between 15 and 85% fuel level.
Right. So if you got a full tank or an empty tank, it's not going to run it.
Or if you have a bad level sensor in the tank.
Oh, there, good point. Yep.
So just something to keep in mind. So the entire system draws vacuum, and then it shuts the purge solenoid off, which then seals the system at either end.
Right.
And then it watches, the computer will then watch the fuel tank pressure sensor and monitor that amount of vacuum in there and watch as the vacuum bleeds up. And it'll slowly bleed up. There's no perfect sealing system. They don't
right.
seal 100%. It'll watch that over a set amount of time. And if it leaks up in the parameters of a 20,000 leak, it would set a small leak code. And if it leaks in the parameters of a 40,000 leak, then it would be a large leak code.
Like you were getting a P0455.
Exactly.
And when you say bleed up, you mean it's a decay, right?
Right.
It's a decay of the
Yeah.
vacuum. Okay.
Yep.
Just so we don't confuse things here.
Sure.
It's not going to increase. It's going to decrease.
Right.
Right? Okay.
The vacuum reading will decay.
Yes.
And you can monitor that.
Oh, very good. Very good. Vacuum reading decays.
You can monitor that with your fuel tank pressure sensor.
Right.
So that's what the computer does. So it takes all those aspects to run this test. So if you have a skewed sensor or you have a fuel tank that's not the right level, it's very hard for the vehicle to run this test. And it's actually one of the hardest readiness monitors to set.
Yeah, it is, yes. And there's a lot of different theories on how to do it exactly. But
sure.
One of the things that we found out is that you actually, it could take 6 different times.
6 drive cycles.
6
yep.
drive cycles, and it has to be 17-hour wait between each drive.
That seems crazy.
It does seem crazy, but you know what? I remember reading once a long time ago, and what they're trying to figure out is how long it takes an engine to get to like minus 20 degrees
okay.
on a very cold day after it's been run. And it actually took almost 48 hours for the inside of that engine to reach ambient temperature at minus
wow.
20, which was shocking to me too. I didn't realize it would take that long, but you think about it, there's a lot of mass there.
Sure.
And if once you get that hot, it's going to retain that heat for quite some time.
Yeah.
And vice versa too.
Interesting.
Yeah.
So I guess the moral of the readiness monitors is if you fix this thing, clear the codes out, if your customer has to go through emissions, it's not going to be able to do it right away. It's going to take maybe a few hundred miles to pass that readiness monitor.
Yeah, if they think they're going to come into your shop and then go take their emissions test the next day, you might want to, give them a heads up and tell them it's a good time to file an extension.
Right, yeah.
Because
yeah.
The chances of that are pretty slim.
Right, yep. Okay, so should we talk about how the system works in terms of a wiring diagram?
Yeah, let's look at electrical.
All right, so if we go ahead and pull that up here, you can see it's a pretty basic looking diagram. You can see all the way on the right side is our purge solenoid, connected directly to our emission fuse, that 10 amp fuse. Goes down to our computer, to the controller inside the computer.
Right.
So
you can see that the computer actually controls that by sending it to ground.
Right.
It's a switch.
And if we look at the vent solenoid in the center, same deal, canister, fuse, 10 amp, powers up our canister vent, and goes down to the control inside the computer as well.
Yep.
But what the diagram isn't showing us here, it's not showing us how the computer is able to monitor that electrical circuit
That's
to
right.
do its integrity check.
Especially, you know, when you get, what was that, a P0449?
449, yeah.
Wasn't it? That said that the vent solenoid had an electrical problem.
Exactly.
You know, so how does the computer see that? How does it see?
Right.
How do it know?
Right, yeah. The computer actually, what it's not showing here is it has a voltage divider type circuit inside of it. So essentially the computer has a voltmeter inside of it, and it's looking for a certain amount of voltage at a certain time.
Right.
So because this circuit here, we'll use our vent solenoid, is powered up all the time, power, when there's no ground supplied to that circuit, power is able to flow all the way to the end.
That's right. It's just going through, and if you look at your diagram there, you see that box with an X in it. That was a question that we had quite a few training classes ago, but that means there's a winding a wire there.
Right. Yep.
Okay, so that current is going to be able to go through that and make it to the computer,
Right.
or to the point that it's switching it to ground.
Right, but if it's not switched to ground at that point, it just stops right there,
Right.
and the computer reads it. So if the computer decides it's not time to turn that vent on, we'll leave it off. It wants to see 12 volts there.
Yes.
Then the computer decides it's time to turn the vent on. It should then see that circuit drop to 0. It should drop very, very close to ground. It might not be exactly 0, but it'll be really close.
Right, and you just did a little test where you went across, we have another vehicle in here today for another EVAP problem.
Right.
Must be EVAP time.
It must be.
And, and you were testing it with your voltmeter.
Right.
If you want to explain that test.
Right.
That's real important
Yeah.
to understand that.
So took the voltmeter and I just hooked one lead into the power side and the other lead into what would be the ground side or the control side of the circuit.
So you went to the 2 pins on the vent solenoid.
Right, unplugged.
Okay.
The connector was unplugged, so I put it in there, turned the vent solenoid on, and I read battery voltage or 12 volts across it. Because one side you have power, the other side you have ground.
Yes.
Which is exactly what we should see.
Right.
So then I went ahead and did the same test with the solenoid turned off.
Yes.
So ungrounded by the computer. Did the same test and I still read 12 volts.
So that meant you were still getting a ground somewhere.
Exactly.
And interesting. So it may be shorted to ground
Could be a short to ground somewhere between the vent and the computer.
Right. So we haven't diagnosed that one completely yet, but we'll keep you informed.
Yeah.
But it's a great way to test that, and it's, you know, once you understand how the system works, then you can understand what you should read at your meter and why.
Exactly.
And what to look for then if it doesn't read like that.
Right, and that's kind of what made this interesting with my car, was it wasn't setting a vent solenoid circuit code.
Right.
It was just setting a large leak code.
Yes.
And that we kind of, when we get over to the vehicle, we'll talk about the way we were testing that and how it
the different tests that we went through. It
threw us for a loop a little bit.
It still is. You know, well, we'll get there. We'll get there. I don't want to
Let's
burst the bubble yet.
Talk about the fuel tank pressure sensor.
Okay.
Fuel tank pressure sensor operates almost the exact same as a MAP sensor. In fact, some vehicles use the same part number.
Oh, do they?
They do.
I didn't know that. Okay, that's cool.
So you got your 3 wires, your 5-volt reference, your signal wire, and your low reference or ground. So
yeah, and it's just a strain gauge. And
exactly.
If you don't understand MAP sensors, we had a training class on that a couple times ago, and we'll put a link in there. And
perfect.
Go back and check that out.
Okay. So, you know how we just had mentioned that it seems like we're getting more EVAP stuff right now?
Yeah.
Well, I think part of that might be because the temperature-related aspect of the test.
And I think you're absolutely right. Go ahead.
According to our data here, the vehicle cold start temperature, so whatever the intake air temp and the coolant temp, has to read between 39 and 86 degrees.
Yeah.
So in Wisconsin,
we're in Wisconsin, and I think last week it got down below 39.
Right.
So it wouldn't run that monitor test.
Exactly.
Which is very interesting. And if you live like in places like Phoenix or whatever, you're going to be over 85 for months.
Right.
So what do you do when you have emissions test coming up, right?
In the middle of winter.
Right. It's like, well, you better warm that car up and then take it for a test and hope like heck it runs that monitor.
We used to leave cars sit in the shop overnight to get
just
to
to get them warmed up and
temperature.
try and get them to run that monitor.
Yeah.
It's a real tricky thing.
Right. All right. Let's talk about that check valve again. Let's get back to that rollover ball.
Let's do that, and that's a real important part, when you go through the testing on one of these. And actually, we have a video that we put out years ago on that. So we'll put a link to that down there if you would.
That was on that Grand Am, right?
That was at Grand Am, right.
Okay.
And it turned out to be the neck of the filler neck was leaking.
Okay.
In between where the insert is. And interesting stuff.
Right. And so when the system tests, like we talked about, it uses vacuum on it, right? So if you're supplying, which the most accurate way to diagnose a leak would be to introduce smoke into the system.
Yep.
And that is supplying a small amount of pressure. Well, if you have that rollover valve and you supply pressure underneath it, it's going to push that valve up and seal off that filler neck.
That's right, because that rollover valve isn't exactly always where it is in this diagram.
Right.
It's over underneath where the filler neck is.
Right.
So once you fill that up with pressure, it's going to push that ball up like the car is flipped over.
Sure.
And stop any fuel from running out the filler neck.
Right.
That's the whole idea.
It seals it up tight.
Right. So now you don't have any smoke going up in that filler neck, and that's one of the key areas you want to start testing, right? So how do you remedy that?
Well, there's a couple different options you have. You could get an adapter like this. This is just a fuel cap adapter that's got a nipple on here to hook up to your smoke machine, and it forces smoke in through the other way, the same way you would put fuel into the vehicle.
So you could actually check the whole system this way with
Exactly.
this. Okay.
And this, if you were to hook this up, this would show that filler neck leaking on this vehicle.
Right.
Because it's not forcing that check ball in any direction that it's not normally.
Yep. And if you don't have a filler cap like this, what's your next option?
Well, then you're going to probably have to pull the filler pipe or the filler neck off of the fuel tank and introduce smoke into it from the bottom.
Like from a cone or
a
from
cone.
a little duck call gadget like this.
Exactly.
And you just stick this up the other, but it's a lot more work.
It is.
To do that, and you'll see in that video that's what we ended up doing. But it does work. It's a lot more work.
Right.
But it does work. So there you go.
Okay. Well, we talked about hooking up the smoke machine to the car. Should we head over there and do that?
You ready to do that?
I think so.
You think anybody got this right yet?
I hope so.
Me too. All right, let's go on over.
All right, let's do it. All right.
All right, here we are with our 2007 Pontiac Grand Prix, your Pontiac Grand Prix.
Yeah, this thing just keeps showing up in here.
Yeah.
Keeps breaking down on me.
Yes, yes it does. Okay, and you had a problem with the P0455.
Right, yep, large leak.
Large leak, and you ended up replacing the vent solenoid.
Yeah, that was the end result.
That was the end result, and so far it's taken care of it.
Right, yeah, I was able to get through emissions.
And this does not have the check ball in.
Correct.
Right, like the diagram showed.
Right.
But, and also, we could not find the test port for this thing.
Yeah, so when we went ahead and smoked it, it was kind of hard to, or different to find how to smoke it.
Right, so let's show them how we smoked it.
All right, well first of all, because this doesn't have this test port, if it did, it would most likely be somewhere right here on this purge hose coming out of our purge valve or purge solenoid. But remember, purge solenoids are going to be under your hood, typically mounted either directly to the intake manifold or with a hose running back to the intake so that it can get its engine vacuumed. This one is bolted directly to it right here. I'm going to go ahead and disconnect the hose. And this is where we're going to introduce the smoke on this one. Normally you'd have that test port to be maybe right here. For whatever reason, this model doesn't have it. So we're going to go ahead and take our smoke machine, and actually before I smoke it, why don't we just make sure that the purge solenoid itself is functioning properly?
Yep.
Because technically we're taking it out of the system right here. We're taking a possible leak source out of the system when we smoke check it. So what we want to do is just hook a vacuum gauge up to it and verify that it is holding vacuum, completely unpowered, not being commanded at all by the computer.
So it's normally
closed.
Closed.
Right. And now I'm going to have to reset up the scan tool because it kicked it out. And let's see what happens here when we turn it on. We should see that vacuum decrease, drop off. It should go back to 0 vacuum. Come on.
See, our scan tools work just like theirs.
Jeez. And now we got it. Okay. And you can hear right away it starts ticking. And we dropped off our vacuum, turn it back off. Stops clicking, holds vacuum, turn it on, immediately drops our vacuum. So we know that our purge solenoid is working. We know that the computer is able to control it, and it's sealing up. It's not causing our leak code. So at this point, you'd want to smoke test the rest of the system. So in order to do that, you need to seal the system up first. So we will go back to our scan tool and now go to the vent solenoid, and we'll turn that on, because the vent solenoid is a normally open solenoid. So as soon as this thing catches up, we'll turn this on, and you'll hear the solenoid actually click.
There it is.
And turn it off, turn it back on. So when it's turned on, the scan tool will read not venting. That means our system is sealed up at this point. We can go ahead and introduce smoke. So we'll turn on our flow control valve, and right away you can see I got smoke pouring out of here, just like this. All right, and I'll go put it into the port we have right here and fill the system up with smoke.
All right, I'm going to pull the cap off back here.
Right, yep. You want
Just
to
to
be able to
verify we have smoke coming through.
Exactly.
And we are smoking back here.
Excellent. Okay, so we got smoke flowing through the entire system. Remember, if you had that rollover valve or that check valve back in the filler neck, you wouldn't see smoke coming out of there.
That's right, and that's the way that you can verify that. Now, if we didn't see smoke coming out, the next step would be to either use that cap that we showed you to go back in the other direction, or to disconnect the filler tube from the tank and go up that direction.
Exactly.
So
somehow to get around that
and
check valve.
that's very common failure on these, is where the plastic insert goes into the steel tube, and they get rust in between there and they start leaking, and it's a tough one to find. And that's that's a good time to bring this up.
Yeah,
where
exactly.
you should have a laser light or a black light. You have dye in the smoke, so then you can put on your yellow glasses and you can see where it actually has residue on it.
Right, and sometimes when you get small leak codes and such, it's very hard to find where the smoke's actually coming from or actually being able to see it, where a laser light can actually help with that. You can see, as we shine the laser light through the path of the smoke here, you can see, as I move it around here, right by our EGR valve there.
The cameras are tough to pick up lasers, but
you can see the actual beam of the laser, where when you're not in the smoke, obviously you can't see it.
Yep.
So that is a really helpful little diagnostic tip, is a laser light can help with that.
Right.
Otherwise, a lot of smoke machines will come with like a super bright light that can really help as well.
Too. Yep. Good tools.
All right. Yeah, that's about it for smoke testing.
Right, and it's that simple. You just have to take step by step and look for the leaks. Now, like we said, we did change that vent solenoid, and we look for a definitive answer as to what actually caused this thing to fail.
Yeah, what failed.
And let's show them how we did that.
Let's do it. So over here on the bench, we have the old vent solenoid. This is the one that came off the car. This is a brand new one. We chopped the hoses off the end. This would normally have a hose coming off.
Right.
Just so it fit on the table, we did cut the hose off.
Right. We have enough problems trying to keep things straight, right?
Right. Okay. Exactly. So do we want to,
the first thing that we did is we checked resistance on it, because remember, it is a solenoid. It's a winding a wire. Yep. When you run current through that wire, you create a magnetic field that pulls that plunger up. Right?
Exactly.
Works just like any other solenoid. So the first thing we did is we checked resistance on it. Let's see what the result was. And right here, this is the failed one.
Yep.
And we're getting 22.8 ohms of resistance.
Okay.
Now let's check.
We don't really know if that's good or bad. Couldn't find a spec anywhere.
We couldn't find a spec anywhere on it.
Dropped one over.
So what we did is we had known good, brand new ones, and we tested it, compared it to that. And by the way, these are manufactured by the same company. It isn't like there's a difference in the aftermarket or anything like that.
Right, exactly.
It's exactly the same. Okay. And when we look at it this way, whoops.
Oh, I got it.
Go. We do see we got 19.4 ohms of resistance.
A little bit less.
So we got 3 ohms difference. Is that enough to say, when you get over 20 ohms, there's an issue? Not
Don't
really.
know. There's no spec.
Not really. There's no spec, but we did check another new one, and it was testing exactly the same.
Yeah, the one that's on the car right now.
Right. So, but still, is that enough to say? Well, not really. Not in my book.
Right, and actually we can show right now that this valve is sealing up. I'll go ahead and get our smoke machine back on and bring that over.
Let's get reset here.
Yeah, I'm gonna go ahead and plug it into right into the vent, and we already got smoke pouring out of this thing again because it's normally open. Powered up, we have our power supply right here.
And that's how it should work on a vehicle too. Like,
Turn it on.
let's say you have a customer that complains about not being able to fill their tank.
Sure.
Okay, this is what's happening when they fill their tank, is the air is coming out through that vent.
Right.
Right?
All right, so I'm gonna power this thing up now. You'll hear a click, and immediately it stops smoking out of there, just a little bit residual.
And there's no smoke escaping at all.
Right.
So there's really no crack or no problem with that to cause it to leak.
Right.
However, if you look closely on here, there is a crack down the side of it, and that was one of the reasons you thought, let's replace it because of that.
Right, yep, it's right on this side here. If we get that picture up, you can see that there's actually physical damage to this
There is a
thing.
crack down the side. Does it come into play? Is that a problem? That was one of the things that we wanted to answer, and that's why we put smoke on it directly and ran it. But there is no leak there.
Right, yeah, we just proved that the valve is sealing like it's supposed to.
It's sealing. There's a crack down the side, but it's not hurting anything.
Right.
Is the way we see it. Okay, so next thing that we did is we actually ran it like it is on the vehicle.
Right.
Like when it's doing a monitor test. While your customer is driving down the road and your computer is checking the circuit to make sure that it is sealing up properly. It'll turn this valve on or closed.
Yep.
Right, and it'll open up the purge solenoid and run vacuum to it.
Right.
Okay, so let's see if it is actually functioning properly. What we did is we put our lab scope on it, and we read the amperage coming off. Let's show them the results of that.
All right, let's take a look here. I got the amp clamp here. I'm on the 1 millivolt, 10 milliamp scale, so the lesser one. Hook it up, and right away you see our amperage increase. We're at, I'd say, between 50 and 60, which really that doesn't mean 50 or 60 amps. That's just the translation from the amp clamp. You got to remember that that's this number right here, this 53.5 or 53, which is our average, actually means a lot less. It's actually 0.53. You got to remember to move your decimal point.
Yep, it's
so
about a half an amp.
Just over half an amp
on that. Okay, so let's compare that to the new one.
Right, and we got another clamp hooked up, and that'll be our green trace. Go ahead, zero this thing out, and we should probably power it up. Ooh.
It's live.
My finger was wet and it got me a little. Oh, gotta love live TV. All right, there we go. So you can see that our green trace here, our second vent solenoid, our new vent solenoid, is actually reading a higher amperage reading. And if we look right here, our flags are right on top of each other, and our scale is the same, 100 millivolts for each. So they are both at the same zero line. They're reading.
It's a side-by-side comparison.
Right. And you can see 51, 52, so just over half an amp, and 64, 65, so 0.65 of an amp. So
there's definitely a difference there, but
tenth of an amp.
That's still, I have a hard time saying, okay, if you're over, 0.6 amps, the thing is good. I have a hard time saying that. Plus, we did find a spec on that.
Yeah, out on Identifix, it said, a guy was saying a quarter to half an amp.
Right, and I don't think that's right.
I disagree.
The new one that we put on, we also checked that, and it read exactly the same.
Exactly.
So yeah, we still didn't find an answer.
Right, and if we were to watch this for quite a while, say a couple minutes, as the solenoids are turned on more, our amperage readings will continue to drop.
It will, as they heat up.
Yep.
And as they heat up, if you want to explain
Right,
that.
yeah. Remember, whenever something heats up, an electrical circuit heats up, it increases the resistance value, and when resistance goes up, amperage goes down.
Ohm's law.
Ohm's law comes and gets us again.
Mike Dale, haunting me. Okay, but there you go. There's another example of Ohm's law actually in the works. It
Practical
makes
use.
a difference, right?
And,
okay, so why did you change that?
well, I lived in a county where I had to pass emissions, you know, and I'm sure you guys have run into it where customers come in, and of course it's the week of their emissions test. You know?
Yep.
That's what always happens.
Yep.
My check engine light's been on. Well, my problem came up every 2 weeks, roughly. Every 2 weeks, I would get that light on, and I had to do something about it to get it through emissions.
And just to explain, you drive about 100 miles a day back and forth to work, so it isn't like it's only checking it, you know, once in a great while. It should be checking, doing an EVAP test just about every day.
You would think, except for this whole 17-hour drive cycle thing, which is
that's interesting too, you know, where you actually have to leave it sit for 17 hours. But so you replaced it actually because it's a common failure.
Common failure, and I noticed there was some physical damage on it, but we just proved that the valve is working just fine.
And the other thought about this is that you get dirt stuck in between the plunger, and the plunger will stick
and not seal
at times.
Yep.
I have a hard time with that, you know, because we should still be able to reproduce that on the bench here. We should be able to make it happen.
Right.
And we haven't found an actual failure on this, and we haven't found a way to actually pinpoint that this is definitely bad at this point.
We even tried freeze spray on there, trying to cool the thing down to, this says it can go down to negative 62 degrees.
Well, the reason that we did that is because when we're going through our checking on this, it was one point where you had checked the resistance on it, and we were at 1.5 million ohms. We took the connectors off, reconnected it, and it read it again.
Right.
And so the next step that we took was, okay, let's activate it once and see what happens then. As soon as we activated it, checked the resistance again, guess what? We were back to our 22 ohms of
and it activated just fine too.
Yep, and it seemed to work just fine too. So if there was actually dirt stuck in there, still, you know, if it was to that point where it's being that consistent and every 2 weeks, you would think that you'd be able to get it back to that position where it actually had failed. But we haven't been able to do that. However, we do have that Colorado that's got a very common problem with it, and we're going to be looking at that next week and see if we can actually come up with something on this.
And there's the TSB out there for like the Silverados and stuff in the mid-2000s where they actually recommend replacing the vent solenoid with a kit that includes a filter for it that you're supposed to remotely mount so that the dirt and stuff doesn't get in there.
So the OEs are thinking that way too. They're thinking that it's a dirt problem, but I would still think you got to be able to reproduce that.
And we weren't, I mean, we've done testing upon testing here and have not been able to recreate the problem.
Not yet, but we don't give up easily.
Right.
Not throwing the towel. What we really want to do is have a way that you guys out there can look at this and say definitively, this is what's wrong. Because the worst thing that happens is you replace this part because it's a common failure, and the customer takes the car, and guess what? They don't pass their emissions test, and you look like a schmuck.
Right.
So.
Yeah, we don't want that.
No, we don't want that. We'll look like the schmucks, but you don't want to look like one.
Right.
Okay. All right. All right. Let's see what the answers are.
All right. Let's see what we got here. So we got Hayward's here. Hayward's Automotive says Tech B. I agree, that is the right answer.
That is the correct answer.
Tech B says that the purge solenoid is normally closed. Perfect, and we just talked about that.
That's absolutely correct.
The vent solenoid is normally open. So we also have NCPD FSB is here. He's saying hi to us, and time to open her up, he says.
Hey, Big N. Whatever.
Yeah, I forgot his name too. I'm sorry, I forgot your name. I believe his name was Mark, but I don't recall. So. And then we also have Randy Charlton here asking, is the car on or off? And if the car is off,
that's a great question.
If the car is off, then it would be open so that you could fill the gas tank. And
right.
Then he said Tech B also.
But when you start up your car, it isn't like it energizes it and closes off that vent.
Right.
that the only time that vent actually closes is during a monitor test, when the system is checking to make sure you don't have any leaks or you do have leaks. That's the only time it actually closes.
Great question, but you did answer it right with Tech B. So if we go ahead and pull up my email, Randy and Hayward's Automotive, if you guys want to send me out an email with your t-shirt size and your mailing address, we'll make sure we get one sent out right away to you guys.
Excellent. Okay. Anything else you'd like to add?
I think that's it.
All right. Me too. All right.
Actually, he just commented in. His name was Drew.
Drew.
I do remember that
Drew.
now.
Yes, I do remember now too.
Sorry for calling you Mark.
Sorry, Drew. All right. All right. Without you being there, we would not be here. We do appreciate it, and we'll see you again next time in Wells Tech Garage.
We'll see you then.
All right.